How does one explain calculus to a potato? In the world of mathematical education, the idea of explaining calculus to a potato might seem absurd at first glance. However, this whimsical scenario serves as a creative exercise to explore how we can simplify complex concepts and bridge the gap between seemingly unrelated entities. So, buckle up as we embark on a humorous and imaginative journey to enlighten our tuberous friend about the wonders of calculus. Setting the stage. Imagine a potato lounging on a kitchen counter, blissfully unaware of the mathematical mysteries that await. Our task is to unravel the enigma of calculus and present it in a way that even a potato can grasp. As we delve into this amusing endeavor, we'll rely on metaphors, analogies, and a sprinkle of humor to make calculus accessible to our starchy companion. The essence of calculus. Calculus, at its core, is the study of change and motion. It's about understanding how things evolve, whether it's the growth of a population, the trajectory of a projectile, or the rate at which your favorite potato plant sprouts new tubers. To explain calculus to our potato friend, we'll start with the most fundamental concepts, derivatives and integrals. The derivative. Peel back the layers of change. Let's imagine our potato as a dynamic entity, capable of change. The process of finding the derivative is akin to peeling back the layers of the potato to uncover the rate at which it's changing. If we were to express this visually, it's like observing how the surface of the potato evolves as we peel away its skin. In calculus terms, the derivative represents the rate of change or the slope of the tangent line at any given point. So, as we peel our potato, we're essentially exploring how its smoothness changes with each layer. A rapidly changing surface corresponds to a high derivative, while a more gradual change results in a lower derivative. The integral. Building layers of potato history. Now, let's reverse the process and introduce the integral. Imagine stacking the potato peels back together to reconstruct the original spud. This rebuilding process is reminiscent of integration, where we accumulate the changes over time to understand the overall transformation. In calculus parlance, the integral represents the accumulation of quantities over an interval. So, as we stack the potato layers, we're essentially summing up the changes to reveal the entire history of our potato's peeling adventure. The integral provides a holistic view, capturing the essence of the potato's evolution. Limits. The potato's infinite potential. To fully appreciate calculus, we must introduce the concept of limits. Imagine our potato growing larger and larger, approaching an infinite size. The limit is the mathematical tool that allows us to explore what happens as our potato reaches this hypothetical infinite state. In calculus, limits help us understand the behavior of functions as they approach specific values. Applying this to our potato scenario, we're contemplating what happens to the peeling process as the potato becomes infinitely large. Does it reach a stable state, or does the peeling process continue indefinitely? Limits offer insight into these intriguing questions. Potato functions. A delicious analogy. Now that we've introduced the basic concepts, let's dive into the world of functions using a delectable analogy. Consider the relationship between time and the crispiness of a potato fry. If we define a function, say f(t), where t represents time, the output, f(t), could represent the crispiness of the potato fry at any given moment. In calculus terms, the derivative of this function, f(t), would signify the rate at which the crispiness is changing with respect to time. A positive derivative indicates the fry is getting crispier, while a negative derivative suggests it's losing its crunchiness. Conversely, the integral of the crispiness function allows us to calculate the total enjoyment of the fry over a specific time interval. It's like savoring the entire experience, from the first crispy bite to the last. Applications. Potato calculus in action. To further illustrate the relevance of calculus, let's explore practical applications that resonate with our potato friend. Imagine a scenario where the potato is launched into the air. Calculus allows us to analyze the trajectory of the potato, predicting its height, speed, and the optimal moment to catch it for a perfect landing. Using derivatives, we can determine the potato's instantaneous velocity at any point during its flight. Integrating this information, we can calculate the total distance traveled by the airborne potato, transforming a seemingly whimsical scenario into a real-world application of calculus. Conclusion. Potato mastery of calculus. In this light-hearted exploration, we've bridged the gap between calculus and a potato, unraveling the mysteries of derivatives, integrals, limits, and functions in a way that even our starchy companion can appreciate. While the scenario may be whimsical, the essence of the explanation lies in the power of creative analogies and relatable metaphors to make complex concepts accessible to all, even to the humble potato on the kitchen counter. So, the next time you ponder calculus, remember the spud-friendly approach, and you might find yourself peeling away the layers of mathematical complexity with a smile.